Hi, everybody. Good morning, and thanks for being here today. Um, my topic today, like Nicole mentioned, is going to be talking about what machine learning. How does machine learning feel if you run it as an engineering discipline? The goal of my presentation today is first to address what it means to run machine learning as an engineering discipline, and then once we establish that, I want us to share a few challenges that many of the organizations have with machine learning, and hopefully some of those will resonate with you. So once we establish the challenges, then you have to come up with a vision for your organization about where is that you want to go from a MLOps perspective. So I want to go over that. And then the next few slides will talk a little bit about how we want to go execute so we can achieve that vision. And finally, I'll wrap it up with a quick summary. So first, let's establish what machine learning as an engineering discipline really means. Delivering business value with machine learning is not just about building a state-of-the-art model. It's also about building an integrated ML system that is able to operate continuously as well as adapt to the dynamic business requirements. And this is pretty common, pretty much in every company. So what does it mean for an integrated ML system? What is an integrated ML system? So it's a system that allows scientists or engineers to collect data, to process the data, and give the ability to manage the features. It is a system that allows us to do continuous integration, delivery, auto training or continuous training along with continuous deployment. I'll touch upon these two subjects a little bit later in my session as well. Something that allows us to train our models very easily and also evaluate them at scale. This system allows us to serve our models either in a batch or online mode very easily. We should be able to track our model metadata and artifacts, and last but not the least, it should have the ability to continuously monitor your data quality as well as model performance, in a continuous manner. So this is what a system, integrated ML system, looks like. And if you have something like this, then you can say that you are running ML as a engineering discipline. So before we talk about the vision we want to have that will allow us to get to the previous slide and all the things that I said over there, first let's look at what the current challenges are in most companies. If you have a large machine learning practice, what generally happens is everybody is trying to innovate in these small teams of scientists and engineers, and they don't have a standardized way of productionizing their models. In many cases, there is no feature store. Even large established companies don't have a feature store, which is kind of crazy for me sometimes. And then data, irrespective of what company you work for or what company you know of, everybody has data challenges. The difference is how much of a challenge the company has with the data, right? So that is where the difference is. Let's go through a little bit about how we can solve data problems. And then, in many cases, there is limited to no monitoring for data quality, or model monitoring in production. We also don't see any operational readiness capabilities built into the system. Scientists are not engineers, and if they don't have a strong engineering counterparts working with them, it's very hard for them to imagine what kind of monitoring and alerting they need for their model to be running indefinitely in production. And lastly, delivering a machine learning model into production, it requires a lot of people from different work streams. Obviously, there are scientists, there are engineers, there are product managers, project managers, analysts. So it takes a lot of people, and generally, each of these work streams are a different organization in the company. So I normally see that there is no much collaboration between these teams, causing to a lot of finger pointing and so on and so forth. So with that background, I want to first share this North Star that I want us to go after. The vision should really be to build and deliver a MLOps platform and tooling that allows our scientists to access reliable data that comes with availability metrics like 4 nines of availability and so on and so forth. The ML platform that we build should enable the scientists to automate data processing, their model building, evaluation, and validation, all those things. They should be able to easily productionize their model either in batch or real-time mode. They should be able to continuously monitor their data and model all the time. And it should also enable the scientists to have a trigger-based mechanism to auto-train their models. And I'll talk about this in a minute in a bit more detail. So, at a high level, if you abstract this away, I like to take this analogy of a ML factory. The idea is, what I'm proposing here, the scientists will bring their model to this ML factory, and they manufacture the various parts of the model in an automated manner. And then after running a bunch of quality checks, they deploy it in production, or it's ready for consumption. So what I'm really trying to say here is we should take away the friction a scientist has to go through with respect to their infrastructure needs. If you take that away, it's a nirvana state. I don't know if any company has really been here, but this is what we should be shooting for. And that's the idea. Now let's talk about what steps we could potentially take. How do we strategize for us to be able to hit this vision? And to me, it's 6 different steps. First is going through an MLOps transformation. We need to come up with a unique way that works for your company to transform how you do MLOps in such a way that every team within your data science organization is using the same technology, same platform to productionize your models. The second one to me is feature engineering. So spending or evaluating a purpose-built or data science purpose-built feature store and building one and managing that feature store is going to help in many, many ways. And many companies have the problem with the skew between training and serving. So having a feature store for both training and serving removes that skew automatically. From a data perspective, you really want to drive your data engineering teams to operate with data as a product mindset. And I'll talk about what that means also in a bit of time. And then data and model monitoring, we need to have comprehensive data quality and model monitoring capabilities. We need to have a tier-based approach for determining how much support a model requires. A real-time model, let's say a recommender system, might require 24/7 support because for most e-commerce companies, recommender systems result in a lot of revenue. So you want to have 24/7 support, mostly from the engineers, in some cases scientists as well. And lastly, you really want to execute as a product team. With all the various work streams involved in each team, you want to be able to execute as a product team. For each of these things that I just talked about, I want to first touch on the MLOps transformation and how this plan looks like. And this is the high-level reference architectural pattern that I've used quite successfully within my organizations. The front and center of this entire architectural pattern, as you can see, is the feature store. If you are able to build ingestion capabilities, data ingestion capabilities into the feature store, then you can easily serve from this feature store both in batch and real time. And you can also use the same feature store for your training purposes. And then you need to have a pretty strong workflow orchestration capability. Lots of products like Airflow and Kubeflow provide this capability. There are quite a few cloud-native serverless technologies as well that allow workflow orchestration these days. So standardizing on the workflow orchestration capability is very important. From a data quality and model monitoring perspective, many companies, even the established ones, they try to build their own data quality monitoring or their own model monitoring capabilities. There are so many startups out there, and there's quite a bit of activity in the industry right now around doing unsupervised learning of your data and pointing out any data anomalies, right? So if your company has that ability to build those kind of things, and you should go ahead and build it. It's probably cheaper. It maybe works better. But then there are quite a few tools out there which I've used in the past, vendor supplied tools, which allow you to monitor both your model as well as data quality. So having some of these capabilities available for each and every team within your organization and giving them some guidance on how they should be productionizing their models using this reference architecture helps a lot. It's the same slide like before. The only difference here is I added the shared library on the left side of the slide. I don't like to give my scientists or my ML engineers access to the feature store or the workflow orchestration engine and whatnot directly. Mainly because if you're operating in a cloud environment or a on-prem environment, you intentionally or unintentionally, in many cases it's unintentionally, people might spin up a service or a model within Kubeflow or even in an Airflow cluster and use up all the resources. Or it can just keep adding several pods in the Kubernetes cluster without your knowledge. Or you run a wild query on your feature store, hogging up all the CPU and memory on the feature store nodes. So the point here is you want to have some guardrails. You want to have some control over how the feature store and the other technologies that you built are accessed and used by your users, in this case, the scientists and ML engineers. So the shared library allows that. And if you kind of abstract away the work each team, a ML team does, everybody is looking to ingest data, everybody is looking to build a model, evaluate a model, and productionize a model. So there are some of these capabilities that you can actually automate. And if you provide a single line code, for example, to ingest data from a well-known data source within your company, you don't have to, each team doesn't have to innovate how to ingest the data. They can just call this function from the shared library and they can do that. If you want to do hyperparameter tuning, again, that's a capability that you can provide through shared library, thereby reducing the amount of time somebody spends in writing their own hyperparameter tuning capabilities. So on and so forth. So it gives you a lot of flexibility and control and velocity too, having a shared library like that. This is just a double click on the reference architecture. It shows, if you look at the left side, there are numerous data sources. There is a batch data store, there is a streaming data source, and there are probably, you are ingesting data from social media sites like Facebook or Instagram, etc. But the whole idea is you ingest all of this data into the feature store, and you manage your features within the feature store. And then you also serve from that feature store, right? So your training, your building your models, everything is based on what's in the feature store. Continuing on my talk here, there are 5 other items that I spoke about as part of the strategy. So first one is feature engineering. So we spoke about how we want to have a feature store. There are numerous feature stores out there. Some of the popular ones that I've used is the cloud native, Google Cloud Native Vertex AI feature store, which I believe works really well. There is also the open source Feast, and companies like Databricks also provide feature stores. Having a single data store for your feature store is going to be awesome, right? If you look at the Vertex AI feature store in the Google Cloud, it allows you to serve your models either in batch or online mode pretty easily. It's a single line of code to do it. And the backend for the system is BigQuery and Bigtable. Bigtable is a NoSQL database. It's pretty fast. BigQuery, as you probably know, is a data warehouse, right? So they automatically move the data between BigQuery and Bigtable for you, so you can serve either in a real-time mode or a batch mode very easily. So that gives you a lot of velocity, so you don't have to really manage the data store so much. And another major part of a feature store is, if you are a large e-commerce company, something like a order ID or a SKU ID is something a lot of the models within your company leverage. There is no reason why every team within your organization should create their own order ID feature or a SKU ID feature. If you had a centralized managed feature store, that team that is managing the feature store can actually build and manage those features for the entire company. So if you create these features once, everybody is going to use it, and since they are managed, the quality is assured. The next one is data availability. You really want to work with your data engineering counterparts and have them treat their data as a product. What it means is, from the point the data is emitted into the data store to the point it is consumed by the end users, which are scientists and analysts and maybe other engineers, they should be owning the data up until that point. Lots of companies have a centralized data engineering team. That is pretty old, and that's passé now. What you really want is a decentralized way of producing data, and also decentralized way of data ownership, right from the data is produced to the point it's consumed. If there are any schema changes or any alterations to the data, the idea is the data owner is going to work with all of the downstream users along with the impact and make sure, if it's models or reports or whatever it is, they all have enough time to update so they can support the new schema or whatever data alterations they made. And all this data, when you say data as a product, it also means data comes with some service level objectives, like 4 lines of availability. If you have event streaming capabilities within your organization, the other thing would be to implement public topics. Again, if you are an e-commerce company, something like order information would be used by a call center data science model or a supply chain data science model, and maybe a bunch of other use cases. So if you had a public topic in your favorite messaging platform, all of these various teams could directly consume from it and be able to take some real-time actions, whatever their use cases. So that's another option. The next aspect is data and model monitoring. You want to be able to monitor your data quality and then model performance, like I alluded to before. Some of the tools that I've used are Anomalo for unsupervised data quality monitoring. It works really well for us in ensuring it gives us data anomaly alerts, so we can take some action on them. We also leverage Aporia for model monitoring performance perspective, and this is where the auto training capability comes in. So let's say you have a continuous monitoring for your model performance, and if it falls below a certain threshold, if the model performance falls below a certain threshold, you could send an alert or you can trigger a training pipeline, an automated training pipeline. So the model gets trained automatically, and once it gets trained, you run more tests on it to see if it is ready for deployment. And if you are savvy enough, you could even potentially do automated deployment in production as well. So imagine a scenario like that, where once you put the model in production and you have all these automated tests and everything, you really could basically forget about that model, because it's just going to automatically retrain itself, automatically deploy, and then it will forever, hopefully provide value to the company. So that is the goal you could aspire for with having data and model monitoring. From an operational readiness perspective, you really want to build a template for your users before moving the model into production. Many organizations that I've been part of, there's always this pressure to provide business value. So people try to put the model in the production, and then you'll see that there are all kinds of operational issues. We don't have proper monitoring and alerting, and there's quite a bit of stress in the system, especially if it's a critical model. So you really want to provide a template for your users, so they exhaustively go through it and ensure they have enough quality controls or monitoring and alerting capabilities built into it. Having a proper CI/CD pipeline is extremely critical for operational readiness. So you have enough tests in place for you to confidently make any changes to the code in production and deliver it quickly. Last but not the least is how to execute as a product team. You really want to build what we call atomic teams or squads or pods, whatever their various names in use, depending on which company you work for. The idea really is for all of us to work together with a common goal, so as to avoid finger pointing. You basically provide a culture in such a way that the team wins or loses based on their ability to meet their OKR, right? So if you drive that kind of culture, the team will stop pointing fingers at each other. They'll try to help out each other as much as possible, because we don't say you are a hero, you made this happen. If something has happened, the entire team gets rewarded. If something doesn't work as well, we say, well, the team failed or was not able to execute as well as we thought it would. Right. So that's pretty much all I have from a quick summary. Building and delivering a fully automated ML system, ML platform, unique to your business is a journey, and potentially could be a multi-year journey. Your journey really starts with targeting a vision that will get your scientists and other stakeholders super excited. So once you have this North Star established, then it's about coming up with a viable execution strategy that works for your company, for your organization, and then basically ruthlessly executing against it. So with that, I'm open to any questions.